Yeah, welcome to Amaxon Renewable and Engineering Company Limited. I remain Engineer Abdulmajid Mohammed Salisu. Uh, if you can remember, we treated solar charge controller in our previous class, and I actually promised that we are going to do interconnection of the aforementioned solar charge controllers. So we are going to start with PWM charge controller, that is pulse width modulation charge controller. Okay. For instance, if we have 60 amps PWM solar charge controller, okay, which means it supports system voltage ranging from 12, 24, 36, and 48 VDC, which means this type of charge controller, its capacity is 60 amps. 60 amps, and it supports this system voltage, whether you are dealing with one battery, two batteries, three batteries, and four batteries. Okay, so now we have to look at the solar panel we are going to connect inside the solar charge controller. If, let's say, we are dealing with 12 volts as our system voltage, if to say we are dealing with 12 volts, which means we have 200-watt solar panel where it is system voltage is 12 volts, 2, and it has, let's say, let's say 8.7 amps as IMP, which is what maximum power current. Okay, so now how many of these 200-watt solar panel can we be able to connect in this PWM solar charge controller? Okay, if we have, let's say, let's say we have 5 number of 200-watt solar panel like this. 1, okay, 2, 3, 4, 5. Okay, if we have 5 number solar panel like this, since our system voltage is 12 volts, you see, if you can remember, we can never see 12 volt rated on the solar panel. Rather, we found VOC of, let's say, 22 point something, from 22 to, let's say, 25 VDC, which means we are dealing with 12 volts. So now I'm assuming, since our panel is 200 watt, which means it is 12 volt. So which means if we are going to connect the panels, it has to be in parallel, because we want to maintain the voltage, and the current will be what? Increased. So as such, we go for parallel connection. So which means we are going to sum all the plus together and all the minus together. So now, if each panel here is producing 8.7 amps, 8.7 amps, 8.7 amps, 8.7 amps, and lastly 8.7 amps. Cumulatively, we're going to arrive at, let me see, 8.7 times 5, which means we will have 43.5 amps. But we are still maintaining 12 volt as our system voltage. So now, if this is the current we are supposed to generate, also we're supposed to obtain from the cumulative 5 number solar panel, which means our charge controller is already 60 amps, which means it can support this current because 60 is higher than 43. But if we go for six number, it has become 52. But mind you, we have to always give a room for a kind of surplus because we don't tend to what exceed the limit of our devices. If we do that, which means it is bound to give us problem because there is nothing that has 100% efficiency. So as such, we have to give a small room for tolerance. So as such, we can either leave it at 5 numbers or maybe we can add the sixth one. But we shouldn't add additional panel because if we do so, which means there will be a problem because we are bound to what exceed the limit of the solar charge controller. This is PWM. All right. So now, if to say we are using MPPT solar charge controller, look at it this way. Okay, we are going to clear here. For instance, we have same number or same capacity charge controller, 60 amps. Okay, 60 amps. Okay, 60 amps, but what? MPPT, maximum power point tracker. Okay, so which means it can also support 12, 24, 36, and 48 BDC. So now, how many solar panel can this MPPT charge controller be able to what? Take? Let us see. Can you remember in our previous class, I told you MPPT has wide range of open circuit. So as such, 60 amps MPPT charge controller has a wide range of 145 volts. It has wide range of up to 145 BDC. Even though the system voltage can support this, and this. So now, remember, since we are dealing with 60 amps charge controller, and here we have 145, and the open circuit voltage of 200 watts, solar panel, let's say is 22 V. So which means how many 22 are we going to connect in series to give us a value close to this or below this? Let me see. We have 22 times 5, 110 times 6, 132. So which means we can be able to connect 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Okay, plus minus, plus minus, plus minus, plus minus, plus minus. So now, cumulatively here, we have 6 panels in series. Okay, 6 panels in series. Okay, now, in series connection, of course, we know voltage is added while the current will remain constant, which means we have 132 VDC as our what? VOC range, okay? And remember, this charge controller has up to 145 volts, which means we are now close to 145, which means we are stopping here. Now, we have 6 panels. Can you remember in using PWM, we only use this either 5 or 6, right? But here, we connect 6 in series. We can connect another 6 again because we are maintaining the current of 8.7 amps, even though the panels are 6. But mind you, the current will remain constant while the voltage will be added. So this is it. The voltage was added. That is why we obtained 132 B DC. while the current remains 8.7. So now, since we have 8.7 here in this string, which means we can incorporate as many strings as possible here. Do you understand? How many strings can we be able to connect before exceeding the limit of this solar charge controller? Let us see. 8.7 times 5, 43, times 6, 52. Okay, so which means we can have up to 6 strings. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay? One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay? Okay? Okay. Series, 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 series. Plus minus, plus minus, plus minus, plus minus, plus minus. Plus minus, plus minus, plus minus, plus minus, plus minus. Plus minus, plus minus, plus minus, plus minus, plus minus. The same thing here. Okay, so at the end, we'll have strings of 6 number solar panels here. We have 6, another 6, another 6, another, and mind you, each we are producing 132V DC 8.7 amps. 132V DC 8.7 amps. 132 VDC 8.7 amps. 132 VDC 8.7 amps. 132 VDC 8.7 amps. Okay, so now we are going to connect all these strings together to give us a cumulative circuit, which means we connect all the negative here together for us to have a negative here, and all the positive together for us to have a positive terminal. So in this case, look at it. How many numbers of solar panels do we have? 6 by 6, which means we have up to 36 number. 36 number on this solar charge controller, 6 by 6. We have 36 panels of 200 watt, all right, capacity. Do you see it? We have up to 36 number solar panels in what? 60 amps MPPT solar charge controller. Can you see? It has the same system voltage, but this one, it has wide range of open circuit, and this is the wide range. We connect them in series to achieve 132 volt DC, while the current will remain constant, which means if we have MPPT, which means we can deploy as many panels as possible. Whereas we cannot try this on what? On PWM solar charge controller, because the only limit it has is 48. And you can imagine this plus this has already exceeded the limit of 48. So can you see it? Because when you connect 2 panels, of course it is going to sense system voltage of 24. But when you add another one, 36. When you add another one, 48, immediately you move to the fifth one, it will give you something different. But for the sake of MPPT, you can have as many strings as possible. This is the case when you are dealing with 12 volt as your system voltage. The same thing with 24. The same thing. What we are going to do, if to say this is 24 volt, which means you look at the range, you look at your open circuit voltage. What are you operating at? Are you operating at 40, 36, 50? If you are dealing with 50 as open circuit voltage, which means you can only connect 2 in series, because if you connect 3, it has exceeded the limit of what? 145, which means you have to move to the bigger capacity charge controller, which is 80 amps or 120 amps, for you to connect panels in series in case you are dealing with a bigger or higher capacity open circuit voltage. And I hope you enjoy this class. Okay, so which means, of course, we have already seen that MPPT deploy more number of panels, whereas PWM has limitation on using solar panels. So which means MPPT is used for a wider application, whereas if you have a bigger capacity system, you can go for MPPT. Whereas if you have smaller application for home use and what have you, you can go for PWM. And I hope you enjoy today's class. Thank you very much. See you next when we are going to discuss on other components of solar system. Bye.